All right, our next problem is a little bit more complex. It is a firework initially at a speed of 1 meter per second is accelerated to 88 meters per second in 0.45 seconds. How far does the firework travel in 2.3 seconds? This is a very two-part problem. So we're going to set up our equations, we're going to set up our variable list, and then we're going to kind of figure out what's our plan of attack, because I want to be able to look at my data just as the data. Okay? So we've got S equals xi plus vit plus 1 half at squared, and a is equal to vf minus vi over t. My variables are s, xi, vi, vf, a, and t. Okay, so I know initially at a speed of 1 meter per second, that means my initial velocity is 1 meter per second. Is accelerated to 88 meters per second in 0.45 seconds. So accelerated to 88 meters per second in 0.45 seconds. So we clearly have two separate parts to this problem because we then have a separate time. That is one key to see that you need to have part A and part B. Because in part B, our time is going to be different. If I'm asking you for two separate time periods, I have a two-part problem that I need to set up two lists of variables for. Likewise, if I had two separate S's that I needed to solve for, I would have a two-part problem that I needed to separate my variables for. So let's go ahead and make our second list of variables. That's going to be another S, xi, vi, vf, a, and t. I already know my second t is going to be 2.3 seconds. Now, in both cases, I'm not asking for after 0.45 seconds, how much farther does it travel in 2.3? I want to know if I have a firework traveling I want to know if it from here to here is 0.45 seconds. If it has a certain acceleration there, I just happen to know my speed at this point. I want to know from here to here being 2.3 seconds, how far is that? So the key thing here is I'm going to have the same acceleration all the way through. My acceleration being constant means at any point along this, it's going to be the same. So my acceleration between here and here is going to be the same from here to here. So the first part, I'm looking for acceleration, okay? Now, if I wanted to check that with my variables, I'm going to say I'm going to have the same starting point for both parts of my problem. So my xi is going to be 0 meters in both cases. Now, my vi is also going to be the same in both cases because I'm still going to have that same starting point. So vi is going to be 1 meter per second. I already have my t. Okay, so the only thing I would be missing in order to solve for s is acceleration. So if you attacked this problem by writing out the variables right away to see what you need to solve this, then you would notice you're missing an A and realize, oh, I need to set up a previous problem. So a lot of this is implied. So really take your time, set up your variables the right way. This is going to be a critical reading skill in this class. So now that our first part is set up, let's solve it for A. I have everything I need to just use the acceleration equation to solve. So part A is equal to VF minus VI over T. I have VF, I have VI, I have T. So I've got 88 minus 1 over 0.45. I'll just plug that into my calculator real quick. That gives me an acceleration of 193.3. Okay. Now remember, my acceleration in both parts is the same. This is another one of those problems that could be easily confusing that you should ask about if you are confused. I will freely tell you. We don't need to get anything wrong on the test because we're confused. So now that I have an acceleration, I have everything I need to plug into my S equation. So for part B, I've got S equals xi plus vit plus 1/2 at squared. S is the variable I'm looking for. Xi is 0. Vi is 1 times a time, 2.3, plus 1/2, and an acceleration of 193.3, and 2.3 squared. I'm just going to put that right into my calculator, and my result will be present. The result of my calculations are 513.58 meters. Installing that in, 513.58 meters. Notice, we don't have a final velocity for this point. We don't have an S for our initial part. We don't need it, but those are missing variables that you could solve for on a test, and that would probably get you into some 4 territory. Thanks, guys.